Hello and welcome to today's lesson on the Earth's atmosphere. I want you to write down the date, title and LO in your books, and then I want you to try the starter task, please. So pause the video here and do that, please. Okay, so I'm not going to reveal the answers to these two questions because that is what the whole lesson is about. So later on you can check and see whether your estimate was correct. It absolutely doesn't matter if you got it completely wrong. It was just for you to have a little guess. So Earth's atmosphere, it is made up of nitrogen, oxygen, argon, and other gases including carbon dioxide. Now, when you think of the atmosphere of the Earth or the air we breathe, everyone always thinks of oxygen. Like there's loads of oxygen. Some people think there's nothing else. Oxygen actually isn't the most abundant in the air. So the word abundant means there's a lot of it. The most abundant gas is nitrogen, actually. So 78% nitrogen, and then oxygen is 21%. Argon is 0.9%, and then other gases, including carbon dioxide, only make up 0.1%. So you can see underneath that it says carbon dioxide only makes up 0.04% of our atmosphere. So when we're talking about greenhouse gases and how pollution is bad for the atmosphere and CO2 is a problem, and then people look at this and they're like, well, it's only 0.04% of the atmosphere. So it's a small number, but it's supposed to only be that much. Like if it's any more, then it's bad for the atmosphere. So if it was 1%, then that would be really, really bad. Even though it's a small number compared to the other gases, we don't want loads of carbon dioxide in our atmosphere. So even though it's a small number, doesn't mean that we can carry on polluting. Right, your task is to use Excel to create a pie chart showing the composition of the Earth's atmosphere. So if we were in school, I would get you to draw this with a protractor and a compass and things like that. But I'm sure a lot of you don't have that at home. I myself don't have those at home, so I can't draw one as a demonstration for you either. So we're going to use Excel. So all you need to do for that is in the first column, you need to write nitrogen, oxygen, argon, and other gases. And then in the second column, you need to write the percentages of each. And then if you go onto the tab that says insert, and then you go to graph, and then you can insert a pie chart and it does it all for you. Okay, so I want you to try that now. Pause the video and I'll continue in 5 seconds. So here is my pie chart. It's not the best looking pie chart in the world. Obviously, we have this really, really thin segment here. You can hardly see it. It's supposed to be green. You can see it a little bit, and that is the other gases, including carbon dioxide. And then we've got another thin segment, but you can actually see it, that's yellow, and that represents argon. Oxygen is the orange segment, and then nitrogen is the pink segment. So it really puts it into perspective, the amounts of the different gases in the atmosphere. So we've got loads of nitrogen, and then the next biggest one is oxygen, and then argon, and then the other gases. So compare your pie chart to this, please, and see whether it looks kind of the same. Obviously, you don't need to use the same colors or the same formatting, but it should look relatively like this. So our atmosphere hasn't always been like this. Over time, it has changed. So you can see that 4.5 billion years ago, so this scale here is time in billions of years, the carbon dioxide concentration was really, really high. And then the methane and oxygen concentration was really, really low. And then as time went on, methane started increasing, carbon dioxide was decreasing, and then we get to about 2.3 billion years ago, which is when there were the first plants, so the first organisms that could photosynthesize. And we know from when we did photosynthesis that plants use carbon dioxide in photosynthesis, and a product is oxygen. So the oxygen started going up because the plants were putting it into the atmosphere. When we get to around here, about 0.6 billion years ago, that is when the first kind of animals appeared. So things like sponges and jellyfish. And then you can see that the oxygen is still going up. And then here, about 0.3 billion years ago, that's when the dinosaurs were around. And you see carbon dioxide is really decreasing and oxygen starts to level off. And then we get to where we are now, and this is what the relative atmosphere looks like. We don't have nitrogen on here. This is kind of just to look at oxygen and carbon dioxide, and we won't talk about methane either. So you can see that if this point here is where the dinosaurs existed, then obviously this over here is a very, very, very long time ago. So this is how it fluctuates over billions of years. If we looked at a graph from today compared to next week's atmosphere, obviously it wouldn't change that much. This is over billions of years. So the way that it's changed, the Earth's atmosphere used to be mostly carbon dioxide with little or no oxygen. We saw that on the graph just. The early atmosphere was formed by gases given out by volcanoes. Nitrogen was released and built up over time. Water vapor condensed and formed oceans. Carbon dioxide dissolved in the oceans. Green plants evolved and started to photosynthesize. So what would this have done to the Earth's atmosphere? I said that on the previous slide, so it would have taken carbon dioxide out of the air and given oxygen out. So oxygen would have started increasing and carbon dioxide would have decreased. So I want you to write a couple of sentences in your book to describe how the Earth's atmosphere has changed over time. So you can use this slide, you can use the slide from before. So just a few sentences or drawings to describe how the Earth's atmosphere has changed over time. Pause the video here and I'll continue in 5 seconds. Right, so inhalation versus exhalation. Now we have done this before, so you should be familiar with it, but I'm going to just go over it briefly again. So I want you to write down 3 comparisons between inhaled air and exhaled air. And can you give reasons for the differences / similarities? So pause the video here and I'll give the answers in 5 seconds. Okay, so air breathed in, inhalation, you have 0.03% carbon dioxide breathed in. But when we breathe out, it goes up to 3%. The reason for this is when we respire, we release carbon dioxide. Second comparison, we breathe in 21% of oxygen, but we breathe out 18%. The reason for this is that we use oxygen in respiration. So when we breathe it in, oxygen is used in the chemical process in our bodies to supply energy, and oxygen is used, carbon dioxide is given out. So oxygen decreases, carbon dioxide increases. And then nitrogen, we have 78% and 78%. They're exactly the same because we don't use nitrogen in any processes when we breathe. So we breathe it in, but then we just breathe it straight back out again. Questions for you to answer. So number 1, what are the 3 most abundant gases in the atmosphere? Which gas in the atmosphere is rising and what are the consequences of this? Why is the air we breathe in not the same composition as the air we breathe out? So pause the video here and I'll give the answers in 5 seconds. So number 1, the 3 most abundant gases are nitrogen, oxygen, and argon. B, which gas in the atmosphere is rising and what are the consequences? That is CO2 and the consequences are global warming. C. Why is the air we breathe in not the same composition as the air we breathe out? When we breathe in oxygen, that is used in respiration, so we don't breathe out as much oxygen as we breathe in. And carbon dioxide, we don't breathe much in, but we breathe more out because that is a product that is released during respiration. Okay, so that is the end of today's lesson. I hope you all have a wonderful day.